Okay, so hi there everyone. We're now in our next video in college algebra, and here we're going to continue with our lessons in radicals. And since we are done with the principles of simplifying or manipulating radicals, it is due time now for us to um, have these lessons in the four fundamental operations of radicals. That is addition, subtraction, multiplication, and then division. And we're going to start off with this addition and subtraction. So in the addition and subtraction of radicals, all similar radicals, when you say similar radicals, those radicals which have the same index and the same radicand are combined into single terms. So in essence, we look at this radicals to be variables. So what we're going to do is to combine the coefficients only when we're doing addition and subtraction of variables. If you can remember, simplifying um, algebraic expressions. Now we're going to simplify radicals. Um, um, Only that it should be similar index. The radicals are similar or with similar index and similar radicand. Okay, so we're just going to add the coefficients, okay, or the numbers in front, okay, of those radicals. So we have some two examples here in this video. So we need to simplify by combining similar terms. Obviously, if they're not similar, that is, they're dissimilar, we cannot combine them in any way, unless we find a way using the laws of radicals or the principles of radicals to make them similar radicals. That is, they have the same index and they have the same radicand. So we have here our first example, square root of 8 plus 5 square root of 50 minus 3 square root of 18. Okay, so we need to make first, as one of the principles in simplifying radicals, we must make the radicand as small as possible. And the index, we have no problem in the index. They're all square roots. So they all have, in essence, an index of 2. Okay, so what remains for us to be done is to make the radicand as small as possible. Okay, make the radicand as small as possible. So what can we do? um, we can extract some factors of 8 here, also a factor of 50, a factor of 18, which is a perfect square. So if we're going to think of 8, 8 is equal to 4 times 2. So if we're going to write it this way, okay, we can write it like this becomes 8 times 2 plus 5. 50 is 50 has a multiple, or rather a factor, which is a perfect square, that is 25, right? 25 times 5 rather times 2, sorry, 5 times 2 minus 3. 18 has a factor of, which is a perfect square, which is 9, okay, times 2. So if we're going to extract all the perfect squares here, oops, sorry, my bad. This is not going to be 8. This is going to be 4 only. It should be 4. Okay, let's rewrite that. Sorry. So that's 4 for here. Okay, now let's simplify further. So we know that the square root of 4 is 2, so we're going to extract that 2 outside. If you want, we can make it like this to make it very thorough. Square root of 4 times square root of 2 plus 5 times square root of 25 times square root of 2 minus 3 times square root of 9 times square root of 2. So that's very clear. That's also one law of the radicals. And let's extract the perfect squares. Square root of 4 is 2. 2 times square root of 2, we can just write it like that. Plus 5 square root of 25 is 5 times square root of 2 minus 3 square root of 9 is 3, and then that's going to be times square root of 2. So we're going to simplify this a little bit further. So we'll have 2 square root of 2 plus 5 times 5 is going to give us 25, and then we'll have square root of 2 over here minus 3 times 3 is going to give us 9 square root of 2. Now, we need to look at and check if they are similar radicals. Do they have the same index? Pretty much, they're all square roots. Do they have the same radicand? So pretty much they have the square root of 2, square root of 2, square root of 2. So therefore, we can combine the coefficients. We might think of them as coefficients, and we will be imagining this square root of 2's to be variables. So this is 2 This is 25, this is minus 9. So 2 plus 25 is going to give us 27 minus 9. Okay, 27 minus 9 is going to give us 18. That's going to be 18 square root of 2. And that's our answer for number 1. Okay, 18 square root of 2. Okay, so that's for number 1. For number 2, let's have one more example here. We have square root of 3 plus the cube root of 81 minus square root of 27 plus 5 cube root of 3. So we have one problem here in which the numbers or the indices are not the same. We have we have squares, we have square roots, we have cube roots and such. So we need to find ways in such a way that they will have the same index at the same time they have the same radicand. So for square root of 3, we cannot do anything with that. We just need to carry that up. That will serve as a something like a signal for us that this can be um, the lowest term for the radicals that we should have as target for that. We have cube root of 81. The cube root of 81, okay, can be um, rewritten as plus cube root of 81. Has a multiple which is a perfect cube. Again, that is 27. 27 times 3 is going to give us 81. You might want to check on that. Minus 27, square root of 27. It has a factor which is a perfect square, which is 9. That's 9 times 3 to be exact. Plus 5. The cube root of 3 cannot be over furthermore simplified. So let's just write it there like that. Since the cube root of 3 cannot be simplified, maybe we might want to group together the perfect squares and the perfect cubes, shall we? So we have square root here minus um, square root of 9 times square root of 3. What happened here? Um, this is the one that I did. So I just already separated the radicals for each of the terms, each of the factors inside. So that's very okay. Plus, we have cube root of 27 times the cube root of 3. Oops, sorry. Plus, this is it. Again, I somehow distributed. Okay, not totally distributed. You may think of that I distributed the cube root to the 27 to the 3. And then we'll have this last term, 5 cube root of 3. Okay? So I think it's the time for us to extract what we can extract with the perfect squares and perfect cubes. So for the next line, we have square root of 3 minus a square root of 9 is 3. Multiply that by square root of 3, it's okay to not write anymore the raised dot. Plus cube root of 27 is equal to 3 because 3 times 3 times 3 is 27. That is 9 times 3. So multiply that by 3 cube root of 3, it's okay not to anymore write the raised dot. Plus 5 cube root of 3. Now notice we have two sets, or like we can imagine them as two variables. This can be an x, this can be a y. These are like forms of x's, these are like forms of y's, in which we can combine them, and um, in this part we can combine them here. We can combine the 3 square root of 3 with the 3 cube root of 3, okay? Because they're not similar radicals. Similar radicals must have um, the same indices, even though they all have the same radicands, but the indices are not the same, so we cannot. So for our next line, this becomes, imagine there's a 1 here, there's a 1 here. So what we have is 1 square root of 3 minus 3 square root of 3. So it's like imagining um, x minus 3x. So what's our answer here? The answer here is actually negative 2x. Only that our x here is not an x. It's not a variable, but it's a radical. So this is going to become negative 2 square root of 3. Okay? Plus, we have 3 square root of 3 plus 5, 3 square root of 3. So that's imagining like 3y plus 5y. That's going to give us pretty much 8y, right? Okay, and then therefore 3 plus 5 is going to give us 8. So that's 8 cube root of 3. And again, we cannot combine them because they don't have the same indices. Okay, remember? So, so this will be the last line for our example number 2. This will be the correct answer. Okay, so that's it for our short video for addition and subtraction of radicals. I hope that you would like and subscribe and you have learned something from here. So thank you very much for watching.